Hello and good morning friends. I am Professor Imran. So today we are going to study logic gates on a simulation software for PLC. Without much ado, let's quickly start. To do the same, I will click on RS Links Classic, which is at the task bar at the bottom. So here it is. Why do we do it? We do it to configure the driver. Now communications is where I have clicked. Then I'll go to configure drivers. Now this is the driver of SLC 500 which is required for my model. So here it is, SLC 500 emulator driver. I'll highlight that and then I'll click on configure. The moment I click on configure, it will ask me to punch in the station number. This station number is of your computer where you will be installing this driver. So I'll click on OK and then I'll click on close. So now the driver is configured so that we can use it. Now I'll have to go to the software where I have already saved program for logic gates. So I'll click on RS LOGIX Micro here at the taskbar at the bottom, and here it appears RS LOGIX Micro. So I'll expand it and now I'll click on File, I'll click on Open, and now I'll have to browse to the specific drive and folder where I have saved it. So here it goes. I'll go to the specific folder. Here it is, and that's logic gates. So I'll click on that and I'll click on open. So this is the program. In the one, this is just in one program. I have taken all the logic gates: NOT gate, AND gate, OR gate, NOR gate, NAND gate, XNOR gate, and XOR gate. So all the logic gates, I've taken different inputs and outputs. So starting with I colon 0.0 and it goes up to I colon 0.11 and I colon 0.12, and at the same time the output goes from O colon 0.0 up to O colon 0.6. So there are 7 outputs altogether. Now in order to use it, first I'll have to verify this ladder diagram. That's a normal process followed whenever you open up a particular software to execute. Always verify that and then save. So I'll click on this tab which says verify project. So the project is verified, which is indicated here, verify is completed, no errors found. Then I'll go ahead and click on file and click on save. The moment I click on save, this is going to register the time 10:004 AM. So when I open it for to run, I'll have to make sure that I use the same program. So to do the same, I'll click on RS emulator. The moment you click on it, you'll get an error message which you need to ignore. So I'll click on OK, and now this is the place where I can either put my PLC in run mode or halt mode. But now I want to execute the program, so I'll put the PLC in run mode. We don't have a physical PLC, so this is a virtual PLC, that is, it is a simulator. So I'll click on file, I'll click on open, and now the folder automatically appears here where I had saved the program for logic gates. I'll browse it, so it's here as I said 10:04 AM. So I'll click on it and I'll click on open. Over here it is asking me to punch in the station number. Now the station number for my computer, what we had seen last, was 00, and that for my virtual PLC is going to be 1. So I'll type in 1 and I'll click on OK. Then I'll click on run. So now I have put the virtual PLC in run mode. So I'll go back to the software. Now I will put the PLC in online mode by clicking on this down arrow, and I'll click on go online. So there it is. Now since it is a NOT gate, so when I have not given any signal, this appears to be on. Now when I right click it and say force on, the output will turn off. I hope that's visible. So again, force off, that means when I don't give an input, the output is high. When I give an input, the output is low. So that's an NOT gate. Then comes AND gate. So first let me put this off. Okay, so now NAND gate. Neither have I applied an input here, nor have I applied an input here, so the output is 0. So let me just turn on one of the inputs. 1, 0, output is 0. So I'll turn this off. off. Now I'll turn this on. So off, on, that is 0 and 1, the output is 0. I'll keep this on, I'll turn this on as well. On and on, the output is on, right? So for 1, 1, the output is 1. Now let's come to OR gate. So for 0 and 0 input, the output is 0. Now let me turn this on. So 1, 0, the output is 1. So let me turn this off and let me turn this on. So 0 and 1, the output is 1. Now let me turn both of them on. So 1 and 1, the output is 1. So we've just seen NOT gate, AND gate and OR gate. Now we'll move on to NOR gate. Now the truth table of NOR gate is 1, 0, 0. So when both the inputs are 0, the output is 1. So let me just make it force off and force off. So this is 0, 0, but the output is 1. Now let me turn one of them on, force on. So the output is 0. I'll again turn this off and I'll turn this on. So again, now this is on, this is off, the output is off. Now let me turn on both the ones. On and on, output is off. So that's your NOR gate. Now let's come to NAND gate. NAND gate, how is the truth table? The truth table is 0, 0, the output is 1. 0, 1, the output is 1. 1, 0, the output is 1. And for 1, 1, the output is 0. So first let me make it 0, 0. So both of them, since it is off, off, that means 0, 0, both the contacts are normally closed, so the output is high. Now I'll make one of them on. So this is on, this is off, that is 1 and 0, the output is 1. I'll turn this off, I'll turn this on. So 0 and 1, the output is still 1. Now I'll turn both of them on. So when I turn both of them on, the output is 0. So that's your NAND gate. Then coming to XNOR. In case of XNOR, when both the inputs are 1 or when both the inputs are 0, the output is 1. So let's see. Right now both the inputs are 0. Let's see how. So I'll make this force off, I'll make this force off. So off means the input from my end is 0, yet the output is on. Now I'll turn one of them on. Since both the address are same, so when I've turned on this, this is also turned on, but this contact has closed and this is opened, so there is no supply to the output. Eventually it is off. So now on and off, output is low. So now I'll keep this off and I'll turn this on. So off and on, the output is low. Now I'll turn both of them on. Okay, both of them on. So on and on, the output is 1. So that's how it is. That's your XNOR gate. Now let's come to XOR gate. In case of XOR gate, if you turn on any one of the input, the output is high. That means for dissimilar inputs, the output is high. For similar inputs, the output is low. So right now I'll turn this on. So one of them is on and I'll turn the other one off. So one section is on, the other one is off, and the output is high. Now I'll make this on. So when both of them are on, the output is low. Now I'll turn this off. So one of them is off, one of them is on, the output is high. So that was about logic gates, that is NOT gate, AND gate, OR gate, NOR gate, NAND gate, XNOR gate and XOR gate. So now how do I stop? There's a process to stop this program. How do we go about? First of all, whichever switches you have operated, make sure you bring them to its original position. Okay, so you got to remove force from everywhere wherever you have applied. So here first force off, then you go to remove force, then you go to remove force. This is a general practice that we need to follow. So off, off, so this has to be off, and then remove force. It is essential that we bring them back to their original position. That's a general practice that is followed. Now, because it is a simulator, that will not make much difference, but in real life, when you're working on the project, it is always recommended to do this. So it is an advice that you make sure that you use it to the fullest. Alright, so now I can go here, I can click on halt, and I can click on file and click on close. So here it goes, go offline, and now I can close the software. So that's it, friends, from my end. You keep watching and keep learning. Thank you.